Hello, this is Dr. Henry, and what we're going to look at in this video is how to write formulas when you're given an ionic name. And we're really going to be looking at a lot of these that contain polyatomic ions. So let's do an example here. All right, so let's say you had ammonium phosphate. So, how do you know this contains a polyatomic ion? Well, first of all, for ammonium, you really need to know that ammonium is the one positive polyatomic ion that you need to worry about when we're writing names and formulas for ionic compounds. So you should just recognize ammonium is the positive cation, polyatomic ion you got to know. And then phosphate. Well, remember, a lot of the polyatomic anions end in ate or ite. So this is not phosphide. Phosphide is monoatomic. Here's phosphide. It ends in IDE. This ends in ate. So you should look at the polyatomic ions. So to write the formula, let's write down the positive ion. And then let's write down the negative ion. So you look on your ion sheet and you see phosphate is PO4 negative 3. So we have a total negative charge of, or phosphate is negative 3. And to cancel out that negative 3, we need a positive charge of plus 3, because 3 minus 3 is 0. So how many ammoniums will it take to get to plus 3? What times 1 will give us 3? Well, we need 3 ammoniums. And remember, anytime you have more than one of a polyatomic ion, it has to go into parentheses. Because if you don't put the parentheses there, like if we say, all right, I didn't put the parentheses, instead of having 3 ammonias, which is what the parentheses tell you, what you'll end up with is it'll be like this. So you'll have 1 nitrogen and you'll have 43 hydrogens, when what you really wanted was this. Because if you don't put the parentheses, you change the formula for the polyatomic ion. You have to have parentheses around any polyatomic ion when you have more than one. All right? So we need 3 ammoniums, that's plus 3. 1 phosphate's negative 3, so that's 0. And then we need to rewrite it without any charges in the final formula. So we just drop the charges and we rewrite it. So here is ammonium phosphate. Let's look at another example. Next example is lead 4 sulfite. So here's our positive ion. Sulfite is our negative ion. And it ends in ITE. So it's going to be a polyatomic ion. So you look lead, the symbol for lead is Pb. The Roman numeral 4 means it's plus 4. Sulfite, you look on your table of polyatomic ions, and sulfite has a formula of SO3, and the charge is negative 2. Now, remember, anytime you're writing a formula, the charges have to add up to 0, right? There's 0. Look at that. I made it into a happy face. It's got a little hair. There you go. There are some ears. Beautiful. All right. So getting back to it. So it's got to add up to 0. So lead is plus 4. So to cancel out the plus 4, we need a negative 4. So if each sulfite is negative 2, what times 2 will give us 4? Well, we need 2 sulfites. So 2, right? If we have 2 sulfites, that'll give us negative 4. So anytime we need more than one of a polyatomic ion, we have to put it in parentheses, and we need 2, so we give it a subscript of 2. So 4 minus 4 equals 0. So we need 1 lead and 2 sulfites, and then we have to rewrite the formula without the charges. And there it is. All right, there's our formula for lead 4 sulfite. Let's look at another example. So next example, and I switch colors here, is chromium 2 phosphate. So you should recognize chromium is a metal. It's got a symbol of Cr. The Roman numeral 2 means it's got a charge of +2. Our anion phosphate ends in, this is ATE. Sorry, my writing's a little sloppy. AT, it's probably a polyatomic ion. So you find phosphate on your ion chart, and it is PO4, and it's got a charge of -3. Now, when you have something like over here, look, this was negative. Sorry, I kind of moved that. This was -2, and this was +4. So it was pretty easy to see that if we had 2 sulfites, that would give us a -4 and cancel this out. But here, this is 2. That's not going to go, 2 times 2 is not 3, it's 4. So the easiest way to do this is to think, what's the smallest common multiple of 2 and 3? And the smallest common multiple of 2 and 3 is 6. So we want to get a total negative charge of -6, and we want to get a total positive charge of +6, because 6 minus 6 equals 0. In all these formulas, the total charges have to add up to 0. So if each chromium is +2, how many chromiums do we need to get to 6? What times 2 will give us 6? And the answer is 3. So we need 3 chromiums. That'll give us +6. Phosphate is -3. We need a total of -6. What times 3 will give us 6? And the answer is 2. And then what did I not do here? What has to happen? If we need 2 phosphates, it's got to go into parentheses, and the 2 must go outside the parentheses. So 2 times -3 is -6. 3 times 2 is +6. This equals 0. So we need 3 chromiums, 2 phosphates, and then we need to rewrite the formula. So here is our rewritten beautiful formula. All right, so hopefully this has helped out. If you need more help, look at the Quizlets. Ask me for help before or after school. I'll be happy to help you anytime. Thank you.